Have you ever wondered how information zips across the globe at lightning speed? The answer lies in a fascinating technology called fiber optics. Imagine a thin strand of glass, as thin as a human hair, capable of transmitting massive amounts of data as pulses of light. That's fiber optics in a nutshell. These hair-thin strands of glass or plastic, known as optical fibers, form the backbone of our modern communication networks. Unlike traditional copper cables that use electrical signals, fiber optic cables transmit information using light, and we all know how fast light travels. This fundamental difference is what gives fiber optics a significant edge over its copper counterpart, but more on that later. Let's first delve into why fiber optics have become indispensable to our interconnected world. Fiber optic cables offer a plethora of advantages over traditional copper cables. Firstly, and perhaps most importantly, they transmit data much faster. We're talking about speeds approaching the speed of light. This makes streaming high-definition videos, downloading large files, and video conferencing a breeze. Secondly, fiber optic cables can carry a significantly larger amount of data compared to copper cables. Think of it as a multi-lane highway versus a single-lane road. More lanes mean less congestion and faster travel times. This high bandwidth capacity is crucial for handling the ever-increasing demands of data-hungry applications. Thirdly, fiber optic cables are immune to electromagnetic interference. This means they provide a cleaner and more reliable signal, free from distortions caused by external factors. This is particularly important in environments with high levels of electrical noise. Lastly, fiber optic cables are incredibly thin and lightweight, making them easier to install and manage compared to bulky copper cables. Plus, they consume less power, leading to cost savings in the long run. Now that we've explored the numerous advantages of fiber optics, let's shed some light on how these cables actually work. At the heart of fiber optic communication lies a simple yet elegant principle: total internal reflection. Imagine a beam of light traveling through the core of an optical fiber. The core is surrounded by a cladding layer, which has a lower refractive index. This difference in refractive index causes the light to bounce back and forth within the core as it travels down the fiber. This phenomenon of total internal reflection ensures that the light signal remains confined within the fiber, even when it bends or curves. To further enhance the efficiency of light transmission, fiber optic cables are often coated with a protective jacket to prevent signal loss and damage. Section 4. Powering the information age applications of fiber optics. Fiber optic cables have revolutionized the way we communicate and access information. From high-speed internet and cable TV to medical imaging and aerospace engineering, fiber optics play a pivotal role in countless industries. One of the most prominent applications of fiber optics is in telecommunications. Fiber optic cables form the backbone of the internet, enabling high-speed data transmission across continents and oceans. They are also used extensively in telephone networks, providing clearer voice calls and faster data transfer rates. Beyond telecommunications, fiber optics are used in medical imaging techniques like endoscopy and laparoscopy, allowing doctors to visualize internal organs with incredible detail. They are also used in sensors for various applications such as measuring temperature, pressure, and strain. Section 5. A bright future, emerging trends in fiber optic technology. The field of fiber optics is constantly evolving, with researchers and engineers pushing the boundaries of what's possible. One of the most exciting areas of development is in increasing the bandwidth capacity of fiber optic cables. With the advent of technologies like wavelength division multiplexing, or WDM, scientists can now transmit multiple light signals over a single fiber optic cable, each carrying a different wavelength of light. This has significantly boosted the data carrying capacity of fiber optic networks. Another promising trend is the development of plastic optical fibers, or POF, which are more flexible and cost-effective to manufacture compared to traditional glass fibers. POF has the potential to bring high-speed connectivity to even more devices and applications in the future. In conclusion, fiber optic technology has revolutionized the way we communicate and access information. Its unparalleled speed, bandwidth capacity, and reliability have made it an indispensable part of our modern world. As research and development continue to advance, we can expect even faster and more powerful fiber optic networks to shape the future of communication.